All right, in this video, we are going to solve these trig identities over here. Let's take a look at the first one. So we want to work on the more complicated side. We're going to work on the left side. And the first thing I'm going to do here is I'm going to make a common denominator. So I'm going to multiply the top and bottom here by cosec plus 1 and the top and bottom here by cosec minus 1. The common denominator is just cosec minus 1 times cosec plus 1. Next, I'm going to expand out all the brackets on the top and the bottom. Cosec times cosec is cosec square. Cosec times 1 is cosec. And on the bottom, I'll FOIL out the two brackets. Next, I will combine like terms in the top and the bottom. So these two just cancel out, and cosec plus cosec is just 2 cosec squared theta. And in the bottom, these two will cancel, so I'm just left with cosec square theta minus 1. Now, I can't really cancel anything here because there's a minus sign there. So my next step is to just change the cosecs into 1 over sine squared in the top and the bottom. So I'll start with the top over there. It's going to have 2 over sine square theta. In the same step, when I'm converting, I'll also change the main fraction into a division sign just to make it a bit more efficient. So cosec square turns into 1 over sine square minus 1. And before I can divide or flip this into a multiply, I need to make a common denominator over here. So I'll write this one the same. And over here, I'll make a common denominator. So I'm multiplying the top and bottom there by sine square theta. Then I'll flip this divide into a multiply. And I'll flip always the second fraction upside down. Then I'll just cancel out sine square and sine square because it's now multiplying, so I can cancel on the top and the bottom. I can't cancel this one here because there's a minus there. So now I'm just left with 2 over 1 minus sine square theta. Using a Pythagorean identity, you should know that 1 minus sine square is just cos square theta. And then I can just convert this to 2 sec square theta, and it matches the other side. Take a look at the second example. Now, both sides are pretty complicated for this one, and if you're allowed to work on both sides, you should definitely work on both the left side and the right side to solve this problem. But for the purposes of this video, we are only allowed to work on one side, which is a bit more challenging. So I'm going to choose to work on the left side because I find that is going to be a bit more difficult. The first thing I'm going to do here is I'm going to make a common denominator on this side. So I'm going to multiply the top and bottom by cot here and the top and bottom by sec over there. Then I'm going to convert everything to sine and cos. For this one, I'll actually keep the double fractions because if I look at the other side, I have a fraction on this side and I have cos, tans, and cosecs over there. So I'm just going to keep it in a double fraction for this one because it's more similar to the other side. I will not switch this to a divide sign. Next, I'm going to simplify if possible. Over here, I can just do cos times cos is cos squared theta over sine theta. Over here, sine times 1 is just sine theta over actually, you know what? I just realized the other side is cos times cot. So I won't multiply this. I shouldn't have even converted that because that's already basically the same. So I'll redo this step over here. I shouldn't have done this conversion. I didn't even look at the other side, but I should just leave it as cos times cot theta. This will become sine theta over cos theta. And then in the denominator, cos and cos just cancel, and I'm left with 1 over sine theta. And then last step, sine over cos is just tan theta. And 1 over sine is just cosec theta. And then it matches the other side exactly. So this one was a lot easier than I expected. The main thing was to work with the left side of the question. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.